Today, let us study about stack. Stack is one of the most important data structure, and it follows LeFO technique. That is, last in first out. That means who comes last, they should go first out. Okay. Let me take an example of like a bucket. Imagine I have a bucket, and I'm going to fill a balls into it. Like you can only fill a single ball at a time, and now you are filling the ball. How can you fill the ball? You can fill the ball from top, right? And how can you take out the ball from the top? Like this, you can remember how this stack works. So why this stack becomes so much important is even recursion. When I was talking about recursion, internally what computer does is it creates a stack. Like imagine a recursion. In recursion, there will be many function calls, right? So what it makes is it will make a function call, then it will make a function call, then again inner function call, again inner function call, and again after returning the values, the values are returned in stack format. Like the recently called function will be returned at first. Like that, we'll reach the end of the recursion, right? Like that, we are going to reach the end. So stack becomes so much important even for us to solve many problems, like parenthesis problem, which is most very famous problem. So, and even it becomes important for computer. And if you are going to extend the discussion, even the many assembly level language and all, totally it is stack is so much important for any compiler in order to solve the program. So stack is so much important. And how to create this stack, I am going to tell you in this video, and I will write the code for that, and that is so much easy to create it. And we are going to use linked list for that. So what I do is I will let me dramatically like diagram, I will explain how it works actually. After that, it will be so much easy for you to understand the code. So let me take another important thing. What you will push, right? The element you will put into stack, right? You know what it is called? It is called push. And if you take out the element, that is called as pop. These are the important words: push, pop, and the element that is at the top of the stack, right? That is called as top. So these are the three important words in stacks. And let's get into the code, how you should create. See, imagine you have a node here. Node will have, what is this structure? I already discussed that node will have a data and a next pointer of the node type, right? So create a node. Okay, you created the node. Then you make it as null. Okay, you make it as null. What is the node name? Node name is top. Okay. Now next you are adding an element. So now you need to add new element. When you add a new element, what you make it as, you make a node by using new node in C++ and malloc function in C. Then you add the data, like you assign the data for it. Let me call it as 10. After assigning, you make this next point to the top. Okay, that is the first step. First step is creating a new node. Imagine you have another node with a null value and its name is top. Okay, that is you already have. Now you will create a new node. That is the first point. Second point is you make that node next point on top. Okay, that is the second point that you are going to do. After that, you make top point on this node. How can you do that? Top is equal to this node. That's it. In code, I am going to take this new node as t. So the first point you need to do is you create a node that is what with the name t. Then assign the data to 10. So you have created the node. Then make t next point on top. So you established a connection. Now what you are going to make is, now the top has to be made as t. Means top is equal to t you need to make, right? That is what this third step is. make top point on T, right? After that, again this process is repetitive and it is iterative, and again I will create another, I am going to add another another data. Like imagine I am going to add like 15. So you create a node name T, right? T, now that will be removed. This variable you are assigning to new node, that is the first step. Then second step, connect that node to the top, that is T next is equal to top. Okay, that is the second step. Make top point on T, that is top is equal to T. So third step, again you have made so that is how that goes on. That is how you will push the element. Let me write a code for that. And another thing, most important thing, I already said you, linked list, they will store in heap. Like there is heap memory is in the computer. So it is a very huge memory, and stacks. Whenever you create a node, when you use new keyword in C++ and malloc in C, it will directly create a memory in that heap memory, in that heap space. So what happens is, it is used, right? So in array you are going to get a stack is full. These messages will, it is a common, because in array there will be fixed size, right? So whenever that array becomes empty, at that time stack will be full. That is what that we get as a result. So in heap, the probability of getting stack is full is low because space is enormous. But still, if you can't create but you may arise to the question like, when you are going to get full in heap, right? Whenever, it's so much important, whenever you can't create a node itself, like you can't literally create a node, like you created a node that is a T, but the T is null. That means you can't create that node at that time, stack is full, so that message you can return. So this is how push works, and I'm going to code that one now. Now I will take str use city struct, and its name is node. Then it has two things. It has a data, it has a no next pointer of node type. Then I will have a top. This is what I said. It is as a you can if you are getting confused, you can write, instead of writing node star top is equal to null, you can actually write like this. You can write like this, no problem. Then there is a top, right? Now what I am asking is for the like, how can I, like I should ask how many element you should push, or what I am going to do is, until the person will give -1 as an input, I am going to add up all the elements. So this will be good, right? So what I am going to do is, I will ask the user to enter the element. He keeps on entering. So whenever he enters -1, at that time I will make I will end the loop. I can do like that, right? Now I will do that thing. Okay, or else what you can do is just make it as push. You can simply do this, it will work. And let me show this first by doing simple push. Now what we are doing is push, right? So I have to write the function for it. So it should return nothing because it is I'm not putting any cout statement, like, okay. Then push, push, okay. Then I'm going to take keyword, okay. After that, what I'm going to do is, I'm going to create a node, as I said, T, the name is T, and T data will be what? It will be key, okay, it will be key. Then suppose if T is equal to null, that means you couldn't create a node itself. Then you do what? You print this statement, that is stack, stack is full, okay. Now what you make is else. If you are able to create, Then what you do is the top, you make T next point on top, right? Okay. Now, yeah, I forgot one thing. See, you need to create a node, right? First of all, to create a new node, you need to write this point. I already said you. So it will create a node. If it can't, then stack is full will be returned to us. Then T next is what? Top. Again, top should be what? Top should be T. So that's it. That's it you need to do. After that, I think that's it what we can do. Then you need to push like pop, like you need to remove the element. Imagine I need to push some more element, like I will push 15, I will push again one, like this I can push any number of element. Actually I can take any element like int n I will take, and I will ask the user to enter the n value, right? I can ask him, so he will give me how many number of element that I need to add, I need to push. Okay, after that I will do for loop. I will enter for loop int I is equal to 0, I less than n, I plus plus. Until then and keep on asking to I will keep on asking the user what is the element that you need to push. N is number of element that you need to push. Okay, x is what is the element that you need to push. Okay, I will get inside get the value of x, then I will do push. Either you can do this or you simply write push, that will also work fine. Then I need to display, right? I need to display whatever I have. How can you whatever I have pushed, you need to display, right? It's so much simple. How to display? Like you are at T top, where will what do you think top position will be at the end of like you are pushing all the elements. Like imagine you had pushed 5 elements, where where will be top will be at the at this point, right? At this left side it will be. Imagine I had pushed 2 elements. Okay, that is 10 and 5. Initially I pushed 10, then 15, after then 15. So top will be always pointing to the recent element. So what I need to do is I need to print this and push the top field, or else I need to take a local variable. I will take a local variable of node type which is pointing to top initially. Let us imagine P. P is a node type, node type pointer which is pointing to top initially. After that we'll print this node. Then I will push. I will do P is equal to P next. That means P will move front. So then you print it. Till where you are going to do this, run this loop, till you reach null, you do this thing. So I can print all of this. Please don't move pointer, because if you move pointer, you will lose the location is behind. So don't move the pointers. Sorry, what I said? Don't move the top pointer. Don't move the top pointer, because you don't need to lose the location. Okay. Now I need to display, right? I will call the function, that is display. Display, I will simply call display, then it should display me everything. It should return nothing. Display, then again what I need to do, okay, let me pass top to it. If I pass top, actually top is a global variable, you can access like that itself, no need to pass it, but still I will take it. And now P, right? I need while P becomes null, while P becomes till P becomes null, you can go on running this loop. So when P isn't null, then what you need to do, right? What you need to do, you need to print P data, right? Okay, I will give some gap. Then what you need to do, you do P next. So that's it. It should work. Now I will run this. Okay, we're asking how many elements that you need to push. I need to push 3 elements. What are they? 10, 15, 1. Okay, it is going to print it 1, 15, 10. As I said, recently top is it at the position that I recently added, the node that I recently added, right? That is where top at. So it will print from this end to this end. So it is normal and logical, because you need to print from top to bottom, right? Like I will show you. You need to print this element, then this element, then this element. Okay, after that, let me pop. Means I should remove, right? I should remove element. What if I need to remove? If you know this, you can do easily. Like you push the top front. As I said, you don't lose the top, because if you lose the top, you will lose the element that is pointing to it. So if you push the top front, then you will lose that element. That means that element is eliminated. So, but still, what I do is I will take a node. I will take a node type pointer. Let me call it as x any name. So I will initially point it to top, and after that I will release this memory. So it is a good practice to release this memory. But actually the main thing objective is to remove this node, right? Top node. So I can just do top next. That's it. Top is equal to top next. But still, it is a good practice to remove this memory. And what I will do is I will also return which is that element I removed. So that is my objective now. So I need to do, right? So for that I will print which is the element that I have that I removed, right? Then I should write pop, then inline, and I should write int it, because it returns me int pop. Then what I do is, before popping, one thing is you need to remember is, imagine there is no element in it, there is an element in stack, then what you will pop? You will pop nothing. So how can you find whether the stack is full or not? It means stack is empty or not. When top is at null, right? When top is at null, you can consider that stack is empty. That means no elements are there. So when top becomes null, when top is null, if top is null, you return me stack is empty. So I can't remove anything, because if empty, because I can't remove anything, because there is nothing to remove. Else what you do is you take a node. I actually said I will take a node, like let me call it as x any name. Then I will take an integer to return, like let me call it as y. Okay, I will point x, right? I will point x to the top. Okay, then what I make is y should be equal to x data, right? Or top data, anything. After that I will make top point to top next, right? Then what I do, I will return y to you. That means which element I have deleted. So now I will run. So I need to push three elements. They are 10, 5 and 15. Okay, 5, 15, 5, 10. Then I should give cout for clear observation. What I do is I will give, okay, cout endline I have given. So the pushed element, I will write some element, the message, the popped element is this, right? That's it. The pop element is this 3 element, 10, 15, 1. So the popped element is 1. Again, if I display, right, you need to check, right, whether we have done we have really pushed popped or not. For that I need to copy and paste display, and I will push 3 elements. Yeah, I have removed popped element is 12, right? So now when I display I have only 3 and 10, right? I will again imagine I will again pop 2 times. Okay, if I display, there should be nothing, right? What if I try to pop another element which is not there? At that time I should get this stack is empty. Okay, I will again give 3, 1 2 3. So this popped element is first it popped 3, then my display was 2 and 1, then I popped 2, then I popped 1, then popped element is stack is empty, it is given. So instead of that, it should have given me like simply stack is empty, that you can see like it is simple. If you change some if and else, if you give, then it will work. But what I am trying to show you is how this stack works. So that is our intention. And return was 500 and something like that, right? Why? Because it was returning a garbage value. X had some garbage value, y has some had some garbage value, that is why it was returning some garbage value. That you can look it after by writing some if else condition. It is so much simple, but you should understand how it actually works. So this is how stack is, and I'm going to make much more videos on stack, solve much more problems on stack, that is like parenthesis problems and these and all. And thank you.